The new kid database security is changing. All right, let's talk data. For years, if you wanted to run a business, you had a server room. It was probably in a closet, maybe with some extra fans pointed at it. Your precious data, all your customer info, your sales records, everything lived on a server that you could physically touch. Securing it meant locking the door, setting up a firewall, and hoping your IT guy, let's call him Dave, remembered to install the latest security patches. This was the on-premises world. You owned the hardware, you controlled the network, and you were solely responsible for keeping the digital bad guys out. It was a straightforward, if sometimes sweaty arrangement. But the game has completely changed. Today, more and more businesses are ditching their server closets for the cloud. Instead of buying and maintaining their own beefy servers, they're renting space on massive, powerful systems owned by companies like Amazon, Google, or Microsoft. Your database no longer lives down the hall. It lives in a massive, climate-controlled data center hundreds or even thousands of miles away. This shift is huge. It's like moving out of your parents' basement and into a high-rise apartment building. You get a ton of cool amenities, but you also have new neighbors and a whole new set of rules to worry about. The fundamental need to protect your data hasn't changed, but how you do it is a totally different ballgame. This evolution from on-premises to the cloud isn't just a simple change of address for your data. It represents a fundamental shift in responsibility and a whole new threat landscape. With on-prem, security was like building a fortress. You built high walls, firewalls controlled the gates, access points, and posted guards, intrusion detection systems. In the cloud, it's more like securing an apartment in that high-rise. The building owner handles the main entrance and the security cameras in the hallway, but you are still responsible for locking your own apartment door and not leaving your valuables out in the open. Understanding this shared responsibility is the absolute key to not getting wrecked. So, why does this matter to you? Because a simple misconfiguration in the cloud can expose your entire database to the public internet. We've seen it happen to massive companies and small startups alike. The convenience and scalability of the cloud are incredible, but they come with their own unique set of security puzzles. The old playbook of locking the server room door just doesn't cut it anymore. You need to understand the new rules, the new tools, and the new mindset required to keep your data safe in this cloud-first world. This isn't just an IT problem. It's a business survival problem. And today, we're going to break it all down. Cloud. It's all about who holds the keys. When we talk about on-premises security, we're talking about total, absolute control. Think of it like owning your own house. You are responsible for everything. You have to install the locks on the doors and windows. You have to set up the security cameras and the alarm system. You have to make sure the foundation is solid and the roof doesn't leak. In the tech world, this means your team manages the physical servers, the networking gear, the operating systems, the virtualization layer, and the database software itself. You control every single layer of the stack, from the concrete floor of the data center to the actual data cells in your tables. This gives you ultimate authority, but also ultimate responsibility. Now, let's contrast that with cloud database security. The cloud operates on something called the shared responsibility model. This is the most important concept to get right. Imagine you're renting that fancy apartment now. The building management, your cloud provider, like AWS or Azure, is responsible for securing the physical building, the lobby, the elevators, and the utility lines coming into the building. In tech terms, they secure the global data centers, the hardware, the networking fabric, and the core infrastructure. They make sure nobody can just walk in and steal a server rack. It's their job to handle the security of the cloud. Your job as the tenant is to handle security in the cloud. The building management gave you a strong door, but it's up to you to lock it. You decide who gets a key. You decide if you're going to leave your windows open on the ground floor. For your cloud database, this means you are responsible for managing who has access to the data, identity and access management, encrypting your data both while it's sitting there and while it's moving, configuring your firewalls and network rules correctly, and ensuring your applications that connect to the database are secure. The cloud provider gives you the tools, but you have to use them correctly. So the core difference isn't about one being inherently more or less secure than the other. It's about a shift in the control plane and responsibility. On-prem gives you full granular control over every single component, which can be great if you have the expertise and resources, but it's also a massive burden. The cloud abstracts away the heavy lifting of physical security and infrastructure maintenance, letting you focus on securing what matters most, your data and how it's accessed. But this abstraction can also create blind spots if you aren't careful. You're trusting the provider to handle their end of the deal, and you absolutely must handle yours. Section 3. The cloud's gotchas, unique security hurdles. Moving your database to the cloud is awesome for scalability and flexibility, but it introduces a whole new class of security challenges that just didn't exist in your old server closet. The biggest and most common risk is misconfiguration. Think about it. Your database is now accessible via the internet by default. Cloud providers give you a ton of settings to lock things down. Virtual private clouds, security groups, network access control lists. But it's shockingly easy to mess up. A single checkbox left unticked or a firewall rule set to allow all can expose your entire dataset to anyone with an internet connection. This is the #1 cause of cloud data breaches, and it's almost always human error. Another major challenge is managing identities and access. In an on-prem setup, access was often controlled by your physical network. If you weren't on the office Wi-Fi, you couldn't get to the database. Simple. In the cloud, identity is the new perimeter. Access is granted based on user credentials, API keys and roles, which can be used from anywhere in the world. This makes managing who has access to what and what they can do with that access exponentially more complex. If an employee's credentials get stolen in a phishing attack, the attacker could potentially access your cloud database from the other side of the planet as if they were a legitimate user. Then there's the issue of compliance and data residency. Different countries and industries have strict rules about where data can be stored and how it must be handled. Think GDPR in Europe or HIPAA for healthcare data in the US. When you use the cloud, your data might be physically stored in a data center in another country without you even realizing it. While cloud providers offer tools to restrict data to specific geographic regions, it's your responsibility to configure them correctly. Failing to do so can result in massive fines and legal trouble. You can't just tell the regulators, "Oops, I thought my data was in Frankfurt, but it turns out it was in Virginia." Finally, the sheer complexity and dynamic nature of the cloud environment is a risk in itself. Cloud resources can be spun up and torn down in minutes. This is great for development, but a nightmare for security if you can't keep track of it all. This shadow IT, where developers spin up a temporary database for a project and then forget about it, is a huge problem. These forgotten, unpatched, and unmonitored databases become easy targets for attackers. Without constant monitoring and automated tools to discover all your assets, you're flying blind, and you can't protect what you don't know you have. It's a constant battle to maintain visibility and control. Okay, so the cloud has its challenges. The good news is that there are tons of powerful tools and strategies you can use to lock things down. The first and most critical strategy is implementing strong identity and access management, or IAM. This is your primary line of defense. The principle here is least privilege. That means every user, every application, and every service should only have the absolute minimum permissions necessary to do its job. Don't give a read-only analytics tool the permission to delete tables. Use multi-factor authentication or MFA everywhere you possibly can. This single step makes stolen passwords dramatically less useful to an attacker. Next up, you have to be obsessed with encryption. Data should be encrypted in 2 states, at rest and in transit. Encryption at rest means the data is scrambled while it's sitting on the disk in the cloud data center. All major cloud providers make this incredibly easy, and sometimes it's even on by default. You just have to make sure it's enabled. Encryption in transit protects your data as it travels over the network, from your application to the database. This is usually handled by using TLS, which is the same tech that powers the little padlock in your web browser. Using both ensures that even if someone somehow gets their hands on the physical drive or intercepts your network traffic, the data is just a bunch of useless gibberish. Let's talk about network security. Even though your database is in the cloud, you can still build virtual walls around it. Tools like Amazon's Virtual Private Cloud, or VPC, or Azure's Virtual Network, or VNet, let you create your own isolated slice of the cloud. You can then use security groups and network access control lists, or NACLs, to act as a stateful firewall, explicitly defining what kind of traffic is allowed to reach your database and from where. For example, you can set a rule that only allows traffic from your application's specific IP address on the specific port the database uses. This drastically reduces the attack surface by making your database invisible to the public internet. Finally, you need robust monitoring and logging. You can't protect against threats you can't see. Cloud platforms provide powerful native tools for this, like AWS CloudTrail, AWS CloudWatch, and Azure Monitor. These services log every single API call and action taken in your account. Who tried to log in? From where? What did they try to do? You can set up alerts for suspicious activity, like someone trying to access a database from an unusual location, or an attempt to turn off encryption. Combining these logs with the Security Information and Event Management or SIEM system allows you to correlate events across your environment and spot sophisticated attacks in real time. One of the coolest things about moving to the cloud isn't just renting someone else's computer. It's getting access to database technologies that were born and raised in the cloud. These cloud-native databases like Amazon Aurora, Google Cloud Spanner, or Azure SQL database come with security features baked right in that are either impossible or incredibly expensive and complex to replicate on premises. These aren't just add-ons, they are part of the fundamental architecture of the service, which is a massive advantage for anyone who wants to, not get hacked. A perfect example of this is automated continuous patching and updates. With an on-prem database, your team is responsible for tracking security vulnerabilities, testing patches, scheduling downtime, and then manually applying the updates. It's a tedious process that's easy to fall behind on. Cloud-native databases handle all of this for you, automatically and seamlessly in the background with zero downtime. The cloud provider's army of security engineers is constantly working to patch the underlying OS and database engine, meaning you are protected from the latest known vulnerabilities without ever having to lift a finger. This alone eliminates a huge category of common security risks. Another superpower is intelligent threat detection. Services like Amazon Guard Duty or Azure Defender for Cloud use machine learning and AI to analyze your database activity logs in real time. They build a baseline of what normal activity looks like for your database. Then, they can automatically flag anomalies that could indicate a threat. For instance, it might detect a query coming from a known malicious IP address, or an attempt to exfiltrate an unusually large amount of data, or a user suddenly trying to access tables they've never touched before. Getting this kind of sophisticated, AI-driven security monitoring on-prem would require a massive investment in specialized hardware and software. In the cloud, it's often just a few clicks to enable. Furthermore, cloud-native databases offer incredible resilience and disaster recovery options that are built in. For example, a database like Amazon Aurora automatically replicates your data across multiple physical locations or availability zones within a region. If one data center goes down because of a power outage or a flood, your database can automatically fail over to a replica in another data center within seconds with no data loss. Trying to build this level of geographic redundancy yourself on-prem would be astronomically expensive, requiring multiple data centers, dedicated fiber links, and complex replication software. In the cloud, this enterprise-grade high availability is a standard feature. It's one thing to talk about theory, but it's another to see how this plays out in the real world. A few years back, a major company had a massive data breach. The cause? A developer had made a backup and stored it in an Amazon S3 bucket. The problem was that the bucket's permissions were accidentally configured for public access. Anyone who knew the URL could download the entire thing. This is a classic cloud misconfiguration issue. The solution wasn't a fancy new security gadget. It was implementing automated tools and stricter IAM policies. Let's look at a more positive use case. A fast-growing e-commerce startup was targeted by a sophisticated SQL injection attack. However, because they enabled AI-powered threat detection, the system immediately flagged the anomalous query patterns. It alerted the security team in real time and provided them with the source IP and exact malicious queries. The team blocked the attacker's IP within minutes, preventing any data from being stolen. This proactive monitoring saved them from a company-ending breach. So what's the bottom line? The move to the cloud doesn't make security easier or harder, it makes it different. You're trading direct control for powerful, scalable tools. For IT professionals, my recommendation is clear. Embrace a security as code mindset. Automate everything. Use infrastructure as code tools like Terraform or CloudFormation to define your security rules. Never rely on manual configuration for critical security settings. Second, invest in continuous learning. The cloud changes fast, and you need to stay on top of best practices. Your on-prem knowledge is still valuable, but it needs to be adapted for this new world. Ultimately, securing a cloud database is a partnership between you and your cloud provider. They provide a secure foundation, but you have to build a secure house on top of it. Focus on the things you control. Strong IAM policies, universal encryption, tight network controls, and comprehensive monitoring. Use the powerful cloud-native tools at your disposal. If you do that, you can build an environment that is significantly more secure. And that's the scoop. If you found this breakdown helpful, hit that like button, drop a comment with your cloud security stories, and subscribe for more tech explainers. Thanks for watching. Or